In this video, I'm going to be showing you how to draw graphs for polynomials. So we're going to start with quadratics. So say we have the equation y is equal to x squared negative 5x plus 4. And we've been asked to sketch this. So obviously first we need to draw an axis. And now, to start our sketch, we need to know three different things. We need to know its roots, so where the solutions on the x-axis are. We need to know its y-intercept, so where it crosses the y-axis. And we need to know its turning point, so where it turns. So we can do this. The different ways of solving quadratics, so you can factorize, and when you put this into a factorized form, that will give you your roots. When you complete the square, that will give you your turning points, and then to find your y-intercept, that's just going to be this value here. You let x equal 0, and that's going to give you y. So we know that the y-intercept is equal to 4, so we can mark this off on the graph. So that's 4. Now to find its roots. You can factorize it, or you can use your calculator. Like I said before, the new A-level relies heavily on calculators. It's actually all calculators, but I'm just going to show you how to factorize it anyway. So x squared negative 5x plus 4, we need to think what two numbers add to make negative 5 and times to make 4. So we know that a negative and a negative will give a positive. We know that this is negative, this is positive. Therefore, in our factorizing, both of our numbers are going to be negative. So what two negative numbers add to make negative 5 are multiplied to make 4? Obviously, negative 1 and negative 4. So we can write that when we factorize it, we're going to get x negative 1 and x negative 4 equals 0. And now the way to find your solutions from this, we know when two things multiply together to equal 0, one or the other or both are going to equal to 0. So let's say we cover this one up and this equals 0. How do we solve this for x? We just add 1 to it. So x negative 1 equals 0. Therefore, x is equal to 1. So we know that on our axis, 1 is going to be a solution. And we're going to do the same for the other one now. If we have the equation x take away 4 is equal to 0, then what's x? Obviously, you just add 4 to both sides. X is equal to 4. So we can put this down here. Now we know our roots and our y-intercept, we can get a general shape of it, but to make it more accurate, we need to know our turning point. And we can do that by completing the square. So, turning point. So to complete the square, what you need to do, so first of all, if there's a coefficient here, you need to factor that out of the whole quadratic. But if it's just a coefficient of 1, then you're fine. So what you do is you open a bracket, you put x, and then you take half of this value. So now it's going to be negative 2.5. I'm going to write that as 5 over 2. So x negative 5 over 2. And then you square that bracket. And then always take away. So this minus here can either be positive or negative, depending on what this sign here is. So you just take half of this value, which here is negative 5 over 2. If it was positive, though, it would be positive 5 over 2. But for this negative, you always do negative. It's never a plus. So what you do now is you take away this term here squared. So that's going to be 5 squared is obviously 25 and 2 squared is 4. So that's going to be x take away 5 over 2 all squared take away 25 over 4 is equal to 0. Now, this here is going to be our x coordinate, but we have to take out and flip it like what we done here. If this is equal to 0, then x take away 5 over 2 equals 0, so x is equal to 5 over 2. So our x coordinate is going to be 5 over 2, and our y coordinate is going to be negative 25 over 4. And you keep this minus here as well. So to this value squared, you're going to add your y-intercept as well. So it's going to be, the completed square format for this is going to be x take away 5 over 2 all squared take away 25 divided by 4 plus 4. Obviously, we can simplify that. Negative 25 over 4 add 4. That's going to give us our y coordinate to be negative 9 over 4. So we know that our turning point is going to be 5/2 and -9/4. So if we put that, then we know that it's going to be 2.5 for our x. So let's just say like there somewhere. So that's 2.5. And -9/4, -2.25, that's going to be somewhere around here. So using a different color now, our graph, we know that it's going to be positive as well, because the coefficient of the x squared is going to be positive. If it was a negative, then it would be like a upside down parabola, but right now it's a positive, so it's going to be a positive shaped arm. So it's going to cut through the x-axis at points 1 and 4. It's going to turn at points 2.5, -9/4. Let me write that down. -9/4. And it's going to cut the y-axis at y is equal to 4. So we can just fill this in like this. And that's how you draw a quadratic. Now, if we're asked to draw a graph that has 3 individual x terms, if we expand this out, our highest degree, so our highest power of x is going to be 3, x cubed, because x times x times x, x cubed. See, this degree here is second degree, this is going to be third degree. So if we're asked to sketch this, we need to know our y-intercept and our roots again. Our turning point, as of right now, we don't know how to do it, but once we get to calculus and derivatives, that's when we can start to find minimums and maximums of graphs. So that's when we're going to be able to find the turning points. But as of right now, you just need the general shape, which you'll get by the y-intercept and the roots. So if we're asked to sketch this, we're going to know that it's going to have 3 roots. So we can write the roots. And much like last time, we're going to set y is equal to 0. So we're going to say this equation here is equal to 0. Then like before, we're going to, if there's 3 things multiplying to make 0, either 1, 2, or all 3 of them have to equal 0. So we're going to take this one, for example, x take away 3 equals 0. So x is equal to 3, because we add 3 to both sides. Then we're going to do the middle one, x take away 2 is equal to 0. So obviously x is equal to 2, because we add 2 to both sides. And then we do the same for this, x plus 1 equals 0, therefore taking 1 away from both sides, x is equal to -1. So we can make these markings on our graph. So we get 3, 2, and -1. Now for our y-intercept, what we can just do is multiply all of our terms together, all of our integers together. So -3 times -2 is obviously going to give +6, times 1 is going to be 6. So it's going to intersect the y-axis at +6. We can also see that if we multiply this out, our coefficient is going to be a positive number, because there's no negative signs on any of the axes, so it's going to be positive. Therefore, it's going to be a shape like this. If it was negative, then it would be shaped like this. But if it's positive, then you can think of it as coming from the third quadrant, and then it's going to be going up into the first quadrant. So we can draw this as something like this. And that's how we draw a cubic. So this is... Now for a quartic graph. A quartic is going to be a polynomial with the highest degree of 4, of x is going to be 4. So if we multiply this all out, we're going to see that we're going to have 1x, 2x's here, so 3x's together with x to the third power, and then multiplying by another x is going to be x to the fourth power. So this one, we also need our roots, and we need our y-intercept, but we're going to find our roots first. So we know we're going to set this to 0. So if we have this, if we get rid of these 2 terms, we're going to see that x is equal to 0. Therefore, one of the roots is obviously equal to 0. So x is equal to 0. If we cover these ones, we're going to see that we have our root, our term x plus 2 is equal to 0. So if we solve this, we're going to get x is equal to -2. But notice this square here. That means that two terms are going to be the same. So that means that we're going to have a repeated root. So x is equal to -2. And let's note that this is a repeated root. And a repeated root, I'll show you once we get to drawing. But all it means is it makes a little bounce on the axis. So now for our third term, we can see that 2 negative x is equal to 0. So then adding x to both sides, we get x is equal to 2. So x is equal to 2. Now for our y-intercept, all we have to do is multiply all of our coefficients together. But remember, this x here is the same as saying x plus 0. So if we multiply 0 by 2 times 2 again, then obviously we're going to get 0, because anything times 0 is 0. So our graph is going to cut through the origin. So now we can draw this. So we know that it's going to cut our axis at 0, it's going to cut at -2, and it's going to cut it at 2. We're also going to know if we multiply this out, we have a negative x term, so it's going to be negative. So that means that it's going to be coming from the bottom, and it's going to be going down at the bottom as well. A positive quartic is going to be like a W shape kind of, and a negative one is going to be like an M shape. So we know that this root here is repeated, and it's going to cut through the center and at 2. So what we can do is we can draw it like this, and then remember what I said, it's going to come and bounce at the repeated root, then it's going to come up through the origin, then it's going to go back down past its second solution at x is equal to 2, and we're going to get this M-type shape.